Okay, I'm going to walk you through particle filter participation project for this class. So first we're going to open the particle filter project attached. Let's see. It's going to be a little different in my world because I've got my Eclipse projects organized in folders. Your particle filter one is probably right there. So we're going to go down. You should have downloaded the Robot Particle Filter Stop project. Going to go inside that, go inside source. Now there are a couple different folders here for this particle filter. We're going to work in the particle filter folder and with this particle filter Java application. Now I'm just going to walk you through some of the other ones real quickly to show you what they are. So this particle filter is organized as a set of particles. There is a particle class here. Every particle has an x and y coordinate and an orientation. That's the direction it's going. We also keep track of its fitness and its probability. The probabilities sum to from 0 to 1. All the particles sum to 1, and the fitness is just a measure of its fitness, and we use that to compute the probability. We have a set of measurements. We take simulated sensor measurements from the particle, and we'll just talk about the measurement class since we're looking at that. The robot itself and every particle has a set of measurement classes. Here we're taking readings, or assuming laser readings or distance readings from a Kinect. Here we're doing 9 measurements in 9 different directions around the robot. And these are the angles of all the measurements. They're all in radians because that's what all these systems use rather than degrees. Okay, so we have these set of particles, and every particle has an x, y, and orientation, and every particle has a measurement it has. With this also we have a GUI, we have a map that's displayed, and the main panel. So that just runs the map and the main panel itself. One thing you could look at when you're running this is inside the main panel. When we do an update, when we click on a button or do an action, does an update, does all these things, and it updates the measurements for the robot and prints out the robot measurements, updates the measurements for the particle filter, and calculates all the fitnesses based on the robot sensor and compares the robot sensor to the particle filter sensors. And then we resample all the particles, and this is what you'll be working on. Now we also could print out all the particle information, and right now it doesn't do that, it just displays it in the screen down here. So if you're having some questions or want to look at that, you can uncomment that. That's in main JFrame here. And then we redraw the map. So that's all in the GUI stuff. Now we're using this on an actually small robot, so there is a robot class here that handles the robot orientation, where the robot is, and where the motor actualization. And then there's some commands here for sending the motors commands to the actual motor controllers. So we are not doing that. The robot itself is disabled, and we're just simulating the robot in this class. Okay, so back to what you're doing. You're working with just the particle filter here. Now, for this participation stuff, you want to scroll down here. We're drawing out the particles, updating the particles, calculating all the fitnesses, and here where we're resampling the particles. So, at this point, we've looked at all the particles, we've calculated each particle fitness, comparing its measurements to the actual robot measurements. And we've calculated, based on those fitness values, a probability for every particle. And you want to change this code, and we'll talk about this more in the assignment. But to get this working, we're going to comment out this where it says students can modify this version. It currently doesn't work, and here's the working version. So we're going to go in here where it says students can modify this. We're going to comment this section out. I'm just going to do a /* there and a / here. And where it says working version, I'm going to end that comment there. And same with here, I'm going to start and end that comment here. So I want to have the working version uncommented. That'll be running for now. And then I can run this simulation. And it should, sorry, I was running a different configuration first. So I forgot to explain, what we do want to do is bring up the the main JFrame here the first time, main JFrame, and make sure we choose run as Java application. Okay, so make sure you have main JFrame open and run it as a Java application the first time. Okay, let's make this up. So this is actually a map of parts of St. Scholastica, what's called Tower Hall at St. Scholastica. Here's my office right there, and here's the robot right outside my office simulated. The yellow dot is where it thinks the robot is, just randomly puts it somewhere, and then all these things are particles. So the robot has pointed in a certain direction. You see a little blue line going up, that means it's pointed up. And each of these particles is a dot and a little line. So we can, let's drive the robot forward a little bit. So I'm going to click forward, and it takes a step forward. And notice the robot does sensor measurements, and we have a number of all the other particles are doing sensor measurements, but if we have them all drawn, it's way too many. It just fills the screen with green lines. So this particle, let's look at this. This particle is facing this way, and it's sensing a long way down through this doorway, a short way straight ahead, short here. And so if we compare that with the robot looks straight ahead and sees a long way straight ahead, and then to the right it runs into a wall. So this sensor reading and this sensor reading are going to be very different, because straight ahead we're going a long way, and straight ahead we're running into a wall here. So these are very different. And so we have all these particle readings all around here, and then we'll rate them and say some are fit and some aren't. So I'm just going to keep going forward here. And now you see they've clumped. We've randomly picked, or not randomly, we've picked the most likely values, particles, and propagate them to the next update here. So now I'm going to turn left. You see my robot turn. I'm going to turn left again. See the robot turn. Again, we're getting clumps, so now it's pretty sure we're in a hallway, because again, our robot can see a long way up and down the hallway, so it's pretty sure we're in a hallway somewhere. And now if I go forward, every time I go forward, it moves the robot, it moves all the particles, so all the particles go in the direction they think are right. Now some of them are going this way, some of them are going that way, some of them are here, some of them there, they're facing. So I'm just going to keep going forward. And again, we're still not quite sure where we are at. We could be here, we could be there. So if I get down here to the end here, it should start thinking of where I'm going, hopefully. Let's do a couple more steps. Okay, so now I'm at this corner. I can see a lot down here, a lot this way. So there's not many places I could be where I could see so far to the left and right and still be here. I could be down here and still there, or up here. So again, if I just turn left and maybe walk a little bit close to this wall. Oops, I think I turned the wrong way. Let's turn around. And again, you can use these buttons, turn left and turn right and go forward. And again, now all the particles are right here. They all think I'm here, and so this is the particle filter worked in this case. Now, the particle filter will not always work. Let's quit this and run this again and see if we can get it not to work. Sometimes, just because of the random nature of the particles, and maybe we just don't have enough particles in our simulation, when we spread them all over the map. So if I just try turning here, and turning here, I may not have a good collection of particles around me. Let's see how this works. Yeah, we have particles going the other way. Yeah. So again, there's no particles right around me, and so it's guessing I'm in some other places. And so in this case, I bet my particle filter is not, see, there's no particles around me, at least going the right direction. There's some here, but they're going a different direction. So here the particle filter really did not work correctly. So what I want you to do for this participation project is to run this a couple times and do various things. Try to go forward, try to turn right, and see, now it thinks the robot's up here. It think we went down here and turned. It thinks we went down here and turned, so it just got to the wrong place. So I want you to run it to about this point where there may be a couple clumps left where it thinks we're at, and then just describe it, or else take a screenshot and maybe run it 4 or 5 times and see if you can figure out what kind of actions will tend to produce better results. Is it better to move forward right away? Is it better to turn right away? What things might help? So again, just comment out this code here where it helps the earn main J-frame here, or particle filter. Comment out the student version that you need to modify, and uncomment out the working version, and run this and see what actions you can do. Run it maybe 4 or 5 times. Either take a screenshot or 2 of it running, or else write a description of where the particles were for the different times, and submit that paragraph to the participation part of this assignment. And this week. And then for the assignment, I'll record another separate video talking about updating this code. Good luck. Have fun with particle filters.